So we're going to start by finding the inverse of x plus 3 cubed. So we switch the x and the y, and the reciprocal of cubed is cube root, so I took the cube root on both sides and I subtracted 3, and this is my inverse then. So the cubic looks like this, and the cube root looks like this. So to verify this graphically, the first thing you have to do is draw y equals x, the line y equals x, because that's what you reflect over. So there's the line y equals x. So the next thing I'm going to graph is the x plus 3 cubed. So that's the cubic. So I would start at 0, 0. The plus 3 means I would shift this way 3. And here are my points. So when I draw, there's my cubic. So when I draw the cube root, this would be the cube root. The minus 3 means I'm going to shift down 3. 1, 2, 3. So here are my points for that. And then here's my cube root. Now to verify algebraically, we're going to do f of g of x, and that has to equal x. And then we're going to do g of f of x, and that has to equal x. And that means they're inverses. So I'm going to start, I would put parentheses around this, and I would substitute it in for x. So when I do that, I would take this whole quantity and substitute it in for x. So I'm going to get the cube root of x minus 3, and then from here I get plus 3 cubed. The minus 3 plus 3 cancels, so I'm left with the cube root of x cubed. So these are reciprocals, so this equals x. So now I'm going to try it the other way. I'm going to do g of f of x, which means I'm going to put parentheses around this quantity and substitute it in here for x. So I'm going to have the cube root of x plus 3 cubed minus 3. So the cube root and the cube are reciprocals, so I get x plus 3 minus 3. So this equals x, so I have x equals x, which means they're inverses. So for this problem, we just have to do f of g of x. So remember, we're going to start on the inside. So I'm going to put parentheses around this and substitute it in for x. The cubic and the cube root are reciprocal, so I get x minus 2 plus 4. So f of g of x equals x plus 2. And then it asks, state the domain. We would have the domain here, the cubic is all real numbers, and the domain for the cube root is all real numbers. So we don't have any restrictions, and we end up with x plus 2, which is a straight line, so the domain is all real numbers. Given h of x equals negative 4 over x plus 2 plus 3, find two functions f and g. So that means we need to figure out the second one that goes into the first one. So the first one we always start with is the parent function. And I know that the parent function is 1 over x. And I know I'm going to substitute x plus 2 in for my x. But what's missing now? I'm missing the negative, the 4, and the plus 3. So now if I substitute this into my f, I end up with this equation here. So that works. So next we're going to graph each function. So I know that this is a 4 and my leading coefficient is positive, so I know the end behavior is up and up. So I know it's a quadratic, and I start at 0, 0 times 2 doesn't shift the 0, 0. And I know my next 2 points are 1 and 1 and negative 1 and 1. So the 2 is a vertical stretch. So my y would be 1 times 2, which would go here. And then this one would go here. So when I graph, this is what it's going to look like. So my domain is negative infinity to infinity. And the range, which is bottom to top, would be 0 to infinity. The x-intercept and the y-intercept would both be 0, 0. The increasing interval, the first interval is decreasing, but the second interval is increasing, so that's 0 to infinity. The decreasing interval would be the negative infinity to 0. This would be symmetric around the y-axis, because you can fold it around the y-axis. There would be no discontinuities. And my end behavior would be as x approaches infinity, f of x approaches positive infinity. As x approaches negative infinity, my y values would also go to a positive infinity. Given the graph of the polynomial function, determine whether the degree is even or odd and if the leading coefficient is positive or negative. Since this is up and up, that would make this even. And since they're up and up, it would also be positive. The end behavior for this one is up and down, which would be odd. And the leading coefficient would be negative. If it was odd and positive, it would be down and then up. And if this would be odd, even and negative, it would be down and down. This would be even with a negative, and this would be odd with a positive. All right, so next we're going to factor. So it starts with the x to the 4th, and that's okay. We're just going to factor like normal. We're going to kind of ignore the x to the 4th to start with. So my a times c is 36, and my b is negative 37, which is going to give me factors of negative 36 and negative 1. There should be an x squared there. So I'm going to do, I have a leading coefficient, so I'm going to have 36x squared minus 36 and 36x squared minus 1. Now I know the first one can reduce. If I divide by 36, I'm going to get x squared minus 1, and then 36x squared minus 1. So if I factor this, I get x plus 1 and x minus 1. And the second one is also a perfect square. The square root of 36 is 6, so I'm going to get 6x plus 1 and 6x minus 1. That's my f of x. And my zeros then would be plus and minus 1, and plus and minus 1/6. If I subtract 1 and divide by 6, I get a negative 1/6. If I add 1 and divide by 6, I get a positive 1/6. So this next example, it starts with x to the third. So I know I have to take out an x. And then I'm ready to factor. I have negative 14 and negative 5, which will give me negative 7 and 2. So I get x minus 7, and x plus 2, which makes my zeros a 0, a 7, and a negative 2. Okay, so next we're going to find the zeros and their multiplicity. So the 0 for here is negative 5 over 2. The 0 for here is negative 4. And the 0 for here is 1. The multiplicity comes from the exponent. And since there isn't one here, that's a 1. So this is a 5, a 2, and a 1. So my odds greater than 1 are going to be a point of inflection. The 2 is a bounce or a tangent, either one, whichever you want to call it. And a 1 is an intersection. For this one, you have to have it in factored form to find these. So you have to factor. So I'm going to factor out a 3x cubed, and that's going to leave x squared plus 4x plus 4. So then when I factor here, I have 4 and 4, which gives me 2 and 2. So when I write this to get this correct, you have to write this with the multiplicity. So I get 3x to the third and x plus 2 squared, which makes my zeros a 0 and a negative 2, a multiplicity of 3, a multiplicity of 2. This gives me a point of inflection, and this is a bounce. So next it says use long division or synthetic division. And so you have to use long division when there's a leading coefficient. So this is a long division, and this one is a synthetic division because it doesn't have a leading coefficient. So the synthetic division, we have to test the actual 0. So the linear factor is x plus 5, which makes my 0 negative 5. And then I'm going to take the leading coefficients, which is 1, 1, negative 17, and 15. Bring down the 1, multiply, add, multiply, add, multiply, add. So it gives me a 0. So here I have x plus 5 times, it started as x to the third, so this is going to be x squared minus 4x plus 3. That's my f of x. But this also factors. I have 3 and negative 4, which is going to be negative 3 and negative 1. Which makes my zeros equal to negative 5, 3, and 1. So the next one is long division. It's going to be a little bit longer. I'm going to start it up here. So I'm going to have 3x minus 2, and I'm going to divide that into 9x to the fourth. Oh, what's missing? The x cubed. And also an x. So I'm going to start by dividing the first term by the first term. So 9x to the fourth divided by 3x is going to give me 3x to the third. So that goes right here. So I'm going to multiply. And then we have to change the sign because we're subtracting. So I have 6x to the third, and I'm going to bring down 5x squared. I'm going to divide the first term by the first term. So I get 2x squared, and I'm going to multiply. Change the sign. These cancel out. I have 9x squared. I'm going to bring down first term divided by the first term. So I get plus 3x. I'm going to multiply. I'm going to change the signs. First term divided by the first term. So I get 6x minus 4. Change the sign. So I end up with minus 8. So my f of x is going to be so it's 3x minus 2 times that, and then here's my remainder. A lot of writing, but it's not very hard. So for sketching the polynomial, the first thing I want to know the degree. So this is 1, and this is 2. So I end up with 1 plus 1, which is 2, plus 2 is 4. So I have a degree of 4. I have a positive leading coefficient, which means this is up and this is up. My zeros are going to be 0, 6, and 2. And my y-intercept is going to be 0 times negative 6 times negative 2 squared, but 0 times everything is 0. So my y-intercept is going to be 0, 0 in this case. And I'm going to have 6 and 2. I know the end behavior is up and up. And I'm going to have a bounce at 2 because of this. So I know the end behavior is up and up. So at 0, I'm going to pass through. At 2, I get a bounce, and at 6, I have to pass through. So I'm going to come up, bounce, go back down, and back up.